Welcome everyone to Is Your Business Running Out of Steam? Make the most of your process steam system. I'm Mary Benson, and I'm from the Ameren, Illinois Act on Energy program. And I'm here with Jerry Eaton. We are both with SAIC, which is an Ameren, Illinois Act on Energy partner. And Jerry also works on the Focus on Energy program in Wisconsin. And today, Jerry's going to be telling you about process steam energy reduction projects supported by the Ameren, Illinois Act on Energy program. Now, quick before we get started, I'm going to cover a couple of practical items. You can hear me, please type a message into the chat window on the right-hand side of the screen. Also, if you have any questions during the presentation at any time, please type those questions into the chat feature and click send, and we will get those answered for you. We'll also have a question and answer portion of the presentation at the end. So I want to let you know the participants are muted so that we won't pick up on background noise and we'll be able to hear Jerry. And also, this event is being recorded, but as you can see, the participants are hidden, and so you won't be able to see who else is logged on, and no one can see you. So, this recorded online training event and the handouts from today's session will be available within the next couple of days on the education and training page of actonenergy.com. And also, once those links are available online, I will email those to you. And also, after this session, I'm going to be sending you a survey, so please provide me with your feedback about how you felt about today's session, and this session is going to last about 60 minutes. Before we get started, I'd like to find out what you already know about process steam systems, so I'm going to give you a quiz real quick, and you'll have about a minute to submit your responses. So choose your responses, click the submit button. Thank you much. Looks like most of you have submitted your responses, so I'm going to go ahead and close down the poll in 3, 2, 1. And I will share these responses with you so you can see the results of the quiz. I'm not going to go over the correct answers at this time. I'm going to wait. I'm going to do the same quiz at the end to see how much you learned, and so at that time I will go over the correct responses. I'll go ahead and share the results with you now. You can see what everyone else responded. And thank you very much for your participation in the quiz. Now, see the topics that Jerry's going to cover on the screen today. And without any further ado, I'm going to introduce Jerry Eaton. He is a PCEM and CPE, and he is a senior energy engineer with Science Application International Corporation, which is SAIC. It's a Fortune 500 scientific engineering and technology applications company. Jerry works closely with the state of Wisconsin's Focus on Energy program. As I mentioned, he helps industrial companies reduce their energy spend, and he has over 25 years of experience in energy utilities, engineering, and facilities management. He received the 2006 Wisconsin Governor's Award for his work in energy management as Energy and Utilities Director at Mercury Marine Corporation. And he has over 20 years of teaching experience and has authored numerous articles on energy management. In 2007, Jerry founded and is the current president of the Wisconsin chapter of the Association of Energy Engineers. And now I will turn this over to Jerry. Welcome.
Yeah, Mary. Again, I'm Jerry Eaton. I'm up here in Fond du Lac, Wisconsin, and we're still over the Green Bay Packers game that you guys all hopefully have seen, and guys being Chicago fans down there in Illinois, I don't know if you like that or didn't like that, but up here in Green Bay, we still got the tissues, and we're still crying about that game. But topics, we're going to go over some best practices in process steam systems. Settings available through Acton Energy, and then how you can get started on your energy-efficient process steam system. When we look at the overall energy usage throughout the U.S., 60% of it is used by commercial, residential, and transportation sector, and 40% is used by the industrial sector. And of that 40%, 30% is steam. So when I go into industrial customer and they have a steam system, I usually want to spend a majority of my time looking at their steam systems. So what I look at now is our opportunity areas associated with the steam. You can hear that entire steam process, about 7% of that goes to the end user, whether it be heating systems or processing systems, or what might want to use the steam for. And the other 30% is some sort of loss. 20% losses go right off the stack. 5% we lose through blowdowns, and that can either be a surface blowdown or a bottom blowdown. Most losses do bottom blowdown. There are about 2% associated with the radiation and convention losses, and everything else about another 3%. So, we can look at downstream opportunities and also with the boiler itself and capture some of the losses associated with these areas. And we can look at each one of those. Steam system block diagram. Again, very, very basic here, but there are 4 components. The generation piece, making steam. We need to get it somewhere, so through the distribution system, get it to the user, and then after the steam has done its job, we want that condensate, if you will, water back through the recovery system, the condensate return system, back to the generation side.
Now I have another quiz for you. We need to know what type of business you represent. And I'm going to open that quiz for you now. And if you could please submit your responses and let us know what business you represent. And other, if you wouldn't mind typing in the chat and let us know, if you'd like to, let us know what other type of business, that would be great too. I do have a lot of others, a couple people from the service industry. We've got from healthcare, one from industrial, and one from commercial. We have someone who works at a utility. Great. Sharing that. I'll go ahead and close the poll and share these results so you can see the final results. Also, we have a couple industrial, so we have a good representation from a lot of different types of business. So, Jerry, that can give you an idea of what type of audience we have on the line here. Thank you all very much for participating in the poll and letting us know what type of business you represent. So I will turn this back over to Jerry.
Great. All right. So let's get into talking about the opportunities and the incentives that may be available to you, and start that now. So, number one, repair replacement. There are a lot of opportunities in this particular arena. Again, with a customer earlier this week, Monday, and had over 78 steam traps, and they had about 28 to 29 was in some type of disrepair or failed or whatever. So we need to take a look at this. If your steam system has not been maintained for 3 to 5 years, it's unusual to see between 15 and 30% of those have failed. If you have your maintenance program, we would like to see those leaky traps or failed traps down to less than about the 5% range. So you can imagine if you have a steam distribution system, 100 to 500, get them up to 1,000, you can have a pretty big loss of energy just in failed steam traps. So the opportunity here then is about steam trap repair replacement program. Testing intervals, depending on what kind of steam pressure you're maintaining through your plant. If it's over 150 pounds, we recommend either monthly. Most of the time we see monthly. Around that 30 to 150 pound range, monthly to a quarterly uses the periodicity. And again, most of the time I've seen somewhere between the quarterly, sometimes semi-annually. Pressure, if it's less than 30 pounds, is a good rule of thumb for those. Opportunity number one, again, steam trap repair and replacement. Annual savings can range from anywhere from $80 to several $1,000s, again, depending on the pressure of your system. And you can use the Act on Energy steam trap application for this measure. And for the steam trap surveys, range anywhere from $30 a trap to $50. So if you haven't done a survey, you can have a site organization come in, do a survey. We'll size that survey up to $30 to $50 a trap. So again, if you have 100 traps and you're getting $50 traps, that's $5,000, which pretty much will cover the cost of the entire survey. And then, based on the number of failed components you have, we will also incentivize you to either repair or replace them, again, depending on if it's an HVAC system or an industrial system, and it depends on the pressure. And if you're around the 100-pound steam pressure in an industrial plant, you can get up to $200 a trap. And in today's replacement program, $200 just to pay for a majority of fixing that trap. So I want you to go after getting a steam survey completed and getting your traps fixed. Opportunity number two is steam leaks. Steam leaks, this self should fix as soon as it's visible. It's not analysis for safety, but from an energy perspective, they're usually up high or in a room somewhere where these leaks happen, and so they're ignored. And they're inevitable. They're going to happen because of the day-to-day wear on your pipes and valves and etc. All right, for steam leaks, there are basically three different ways that you can identify a steam leak. Most common is you just see it. Sound. This one is some type of electronic device. Leak can save you 400 for the smallest leak, up to several thousand, if not tens of thousands, depending on the size of the leak. Again, if you have it that's identified, you act on Energy Custom Application Form, measure, the program will pay $1.20 per therm for fixing those leaks. So again, a good deal between fixing your shafts and repairing your steam leaks. Questions at any time throughout this presentation, don't hesitate to go ahead and type it in there, and I'll try to answer it as I get them. Number 3, tuners. Some people call it the tuning of the burners, but improving boiler combustion efficiency. Often operate at excess air that's actually higher than normal, and if you exactly the right amount of air to the amount of fuel, that's called the stoichiometric combustion line, and that'd be the most energy efficient point you could possibly be. We don't operate there. We usually want to operate around 2 to 3% excess air because we want to make sure that we burn off all the natural gas in the process. But depending on how old your burners are and stuff, sometimes those linkages and stuff can be very flimsy, and be operating with excess air about way up in this range, and that becomes very, very inefficient. We use a computer-based analyzer to do this. Very few people do in-house. Usually up to an outside agency that comes in, again, based on the periodicity I mentioned before, and do a tune-up of the burner. And I like to see somewhere around that 3%, definitely much more, not more than 3%, but turn that 2 to 3% oxygen level, or what we call 15% excess air. Rule of thumb is we can increase our boiler efficiency about 1% for each 15% reduction in excess air, and then talk a little bit more about ways we can reduce the stack temperature, but get about a 1% savings for each 40-degree temperature drop in the stack. Having that, if you do tune-up, sit down with the person that did the tune-up and listen to what he has to say. You know, was the tune-up we're running way out here in excess air? Periodicity you're using shouldn't be air. Maybe it should be 6 months. If it's fine that the tune-up you did very little bit of minor adjustments, then maybe that periodicity you're on right now is good enough. But doing your adjustments, you probably don't want to be using that periodicity. You might want to cut that down and more often, because again, the amount of energy that's wasted when these things are operating way up in this range here could cost you a lot of money. Again, tune up the burners here. Like savings can range from several hundred to several thousand. I guess it's a relatively low cost measure to have somebody come in and tune the burners. Back on tuning up the burners usually is somewhere around that 1 to 2 year payback. Again, depending on how big your burner is and how big the boiler is. Will help button incentive size. You get burners tuned up. Annual savings, again, like I mentioned, several hundred to several thousand. But again, depending on the size of your burner, in kH, which uses BT per hour, if you have 1,000 KUs or 1 million BTUs per hour system, the boiler incentive size to a price of $900. So again, it should almost cover the cost of tuning the burners. Use your HVAC/water heater application for this measure. number 4, insulation. The rule of thumb on this is any pipe that is greater than 120 degrees shouldn't be insulated. And again, we're seeing paybacks from 6 months to about the year and a half time frame. So it's almost you can write out of your maintenance budget to get this done. But in on many audits, and I walked through some boiler rooms, some of the places that the boilers and stuff are at, and where the steam pumps are, and condensate return lines, and today there's still many miles of pipe that has not been insulated. Insulation reduces energy loss from piping and equipment services. And again, we want you to get this insulated. Here's examples of pictures that you can see, just the workmanship on the insulation. They've got hanging all over the place. Again, the amount of energy that's you're losing out this pipe to get it done, it just makes economic sense. Okay, and you want the Act on Energy Custom Application for this measure, and this measure is again $1.20 per therm. And again, if you have a side firm come in, he can give you a complete item by line item, the size pipe, the temperature pipe, cost to fix lines, and the energy savings, which is each line item, and we'll set aside that when you get that fixed at $1.20 per therm.
Jerry, now we have another quiz question for you. We would like to know, Act on Energy custom projects require pre-approval. I don't know if we've covered this, so just a reminder. Looks like most of you have answered. Go ahead and close down the poll in 3, 2, 1. And looks like most of you have said yes, they do require pre-approval, and that is definitely true. If it's a custom, if you're looking at one of the custom measures that we've mentioned, you're going to want to complete the application, estimate those incentives. If it's over $10,000, go ahead and submit that for pre-approval, and then you will get a pre-approval letter knowing that you can go ahead and start purchasing equipment and begin the work. So thank you very much for participating in that, and I'm glad that you knew the correct answer. So I'm going to turn this back over to Jerry.
All right, thanks. Now we're going to start talking. The previous opportunities were pretty low cost, and again, with the program providing incentive dollars, relatively low cost to get those things completed. We're going to get into a little bit more capital-intensive types projects, and the one we want to look at is opportunity 5, which is upgrade the burner itself. And you want to provide the proper air-to-fuel mixture throughout the full range of your fire rates and without constant adjustments. Measures with complex linkage designs do not hold their air-to-fuel settings over time, are adjusted to provide high levels of excess air to account for inconsistencies in the burner performance. And we've talked about is over time, these linkages become a little excess air is introduced into the burner, and it becomes wasteful. And a natural gas burner only requires, again, about 2 to 3% excess oxygen. Or another way of saying that is 10 to 15% excess air. There's a 5-to-1 ratio there. So if I say it's 2% excess oxygen, that's 10% excess air. and we want to burn the fuel without forming excess carbon dioxide. And a burner today's market should have somewhere down ratios of 10 to 1, 12 to 1, with little or no loss in combustion efficiency, and that's what we're going to strive for. An energy-efficient burner, though, should be considered if repair cost becomes excessive, reliability becomes an issue, or introduction are significant. For example, consider purchasing a new energy-efficient burner. If the burner is cycling on and off rapidly, if coming on and off, or what I call short cycling, then it might be time to take a look at that and put in a better burner with a better turn-down ratio. The potential energy savings by replacing your existing burners with an energy-efficient burner requires several steps. First, recommended burner maintenance requirements and tune your burner. Going and you do it yourself. You have the means of doing so, a combustion efficiency test, and a full load, and then usually 75% load, 50% load, and 25% load, and just again try to figure out what's the efficiency of each one of those levels. And then when compare with that new burner, if it makes economical sense, then obviously move forward. Now, if you do decide to replace the burner, like it's a custom application, so you need pre-approval to do this project. The incentive for this measure is $1.20 a therm. It'd be pretty significant on a burner replacement. And there's cost depends on the size of the overall system. 26 is with annual maintenance of your system is called Waterside heat transfer services. Scale buildup doesn't take much of a scale to really reduce the transfer of heat and reduce your overall energy efficiency of your boiler. Fuel weight to the boiler scale may be 2% for the water tube and up to 5% for fire tube. And when I say scale buildup, we're talking like a 64th, maybe a 32nd of an inch of buildup on the pipe. So we're talking a very small amount of scale buildup, and you lose 2 to 5% of your efficiency. So it can be pretty significant. And again, what I want to say here, when the firm is cleaning, or if you have your internal staff as well, and they're opening up the boiler and cleaning the tubes, just out and go out and look at it and see what talk to the maintenance guy, talk to the outside vendor, and ask him, what's it look like? Maybe your tree needs to be tuned up a little bit to make sure we don't have scale built up. Clean the Waterside heat transfer services. Again, this is a custom measure. You'll need pre-approval. Incentive for this measure, again, is $1.20 per therm. Low to medium cost measure that can be paid using either your maintenance budget, expenses, or you add to another measure through capital funding. And this best practice can have paybacks of usually less than 2 years. Number 7 is require the waste heat. Like I said in the diagram, down and bottom blowdown is needed for chemistry control. However, it can have a lot of loss of energy that can be recaptured into some process. Again, capital intensive, and assumptions we want to talk about is return on to the boiler. After the steam is used, what is your condensate return? Most companies don't even know what that number is. Are you returning 70% of your steam back to the condensate return system, back to the boiler, 8%, or 0? And doing 100%. Some systems are using direct steam, so that's impossible. However, some places will see condensate return lines that are cut off, or valves are shut off, or because of growth and changes and process and stuff, lines are just not hooked up properly. So again, take a look at your condensate return to make sure you're getting the type of return back to the boiler, and you can tell by the amount of makeup water you need on any given day. Cover heat from the boiler blowdown. If you can use heat somewhere else, put in a type of heat exchanger to capture that heat is a possibility. The other is on the boilers, adding some type of economizer on the stack to heat the incoming feed water or preheat the combustion air. And usually those systems are about a 3 to 4 year payback, and then to help with the program, maybe that down to a 2 or 3 year payback. And again, it's a nice little project to take a look at. If you don't have any economizer in your stacks, take a look at that and see if there's an opportunity there for. And the other type of heat exchanger on the circle blowdown and bottom blowdown, if you have a place to add that heat, maybe you want to heat up some hot water in a different process, maybe back into the deaerator, and a lot of different options associated with those either the stack or the blowdown lines. Change and reuse, again, is custom applications for these type of measures. The energy incentive for these measures, again, is $1.20 a therm. These are medium to high cost measures that require capital funding. Again, an economizer can, again, the size of the boiler can be $20 to $30 to $50, depending on the type of economy you want. Plus another $20,000 to install it, and depending on how much piping you need, another $10,000 to $20,000. So we're talking some large type of projects. Excuse me. And so work with vendors and work with your advisors to put the project together and see if it makes financial sense for your particular company. Again, best practice have a range of paybacks depending on the system usage, etc. All right. So I'm going to recap real quick on our summary of process steam opportunities for energy savings. Steam repair and replacement incentive, again, somewhere between $100 and $400 a trap, depends on the pressure of your system. The application you want to fill out is the standard steam trap repair replacement application. Steam trap survey, the incentive is $30 to $50. Standard steam trap survey, trap repair and replacement application. And again, usually we try to couple these together. Do the steam trap survey. Get this paid for, incentive program, and a list of all the different steam traps that are in your facility, and determine how many of those steam traps you want to get replaced or fixed, and then get the incentive for that as well. The companies I go through don't even know how many steam traps they even have or located. So getting steam traps trap survey done. First step, I highly recommend that. Again, it gets you a nice list of where the traps are, what they're used for, where they're located, and how many you have. And also tell you the amount of energy you're losing because they have failed, and get an idea of the units there. So this is a program, and again, with the Illinois program helping you out, this almost makes a process to get this done. Repair dates. Again, this is going to be a custom application, need pre-approval. And again, with this, leaks and stuff, not only is a safety issue, but steam leaks in itself is very expensive, and will help you fix steam leaks at $1.20 per therm. Two burners, you're probably doing that anyway. Again, I want you to keep that program going. Use the HVAC water heater application. Or it's a very large boiler, over 2 million BTUs per hour type boiler, then you need to use some application form for that. Again, like I mentioned before, when you're tuning the burn, go and see what the outside agency, if you're not your internal maintenance guys, watch what they're doing. Are they just coming and doing a quick adjustment, or are they taking their time explaining exactly what they're doing? Learn from the vendor what they're doing so you can understand, the adjustments, and then read the results. The results are, you have, 5-6% of excess oxygen, or 15% excess air. You probably are not doing periodicity correctly. You might shorten that down a little bit. Okay, so doing it a year, you're open to the boiling anyway because you want to do a cleaning of it. At the same time, the tune-up, and you find that tune-up is way out there. Then maybe you want to do that tune-up every 6 months or every 3 months. Again, you want to make sure those burners are operating at its best efficiency you possibly can. Again, you want to insulate any pipe to 120 degrees. You put a temperature on available. You can shoot the pipe. What's nice about it, you can shoot it up in the overhead. And if pipes are over 120 degrees, get those pipes insulated. Again, the paybacks are extremely short on those, especially when you go after a custom application and get an additional $1.20 a therm saved. So not only are you getting the incentive, you're saving a heck of a lot of energy. And so that's on hot water, that's steam distribution, your condensate return. And it's out there in the refrigeration world. I'll just throw this out there so we're talking about insulation. All refrigeration lines should also be insulated. Okay? The next one is, again, a little bit more intensive as far as cost goes. Energy efficient burners. Do the analysis, and again, if your system is short cycling or your efficiencies are not where they need to be, get a combustion efficiency test done at 100%, 75%, 50%, 20%, 25%, and see if replacing a burner makes sense. This is a custom application, and you're eligible up to $1.20 of a save by replacing that burner. Waterside heat transfer surfaces, usually done when we do the tuner burners. Like I said before, again, go when the business guys or whatever are doing that, and see exactly what he's doing, and see what the scale build up. Maybe the chemistry is out of whack. Maybe it needs to be fine-tuned as well, as you do have build-up. If you do, you need to address that. And again, to clean those surfaces will help that as well. Application which needs pre-approval and $1.20 per therm. your waste heat and reuse it. If you stack your boiler, there's no heat recurring on that stack. It's a relatively large boiler. You might want to start thinking about an economizer to either preheat the combustion air or preheat the feed water going into the boiler. Your incoming water is 170, 180, 200 degrees from a tank, and increase that by 10 or 15 degrees by using an economizer. That might make economical sense. And then you apply for a custom application and get $1.20 a therm. Usually it does make economic sense when you add that incentive in there as well. So a lot of opportunities with the steam system. It's used. You have a steam delivery system. It's usually a pretty big chunk of your overall energy spend. And again, usually when I go and do an audit, I want to look at that particular system first because it is really, really attractive. Examples of Act on Energy Steam Trap projects that were completed. And it's a company in Mount Vernon. I can't tell you the company, but they placed 134 steam traps that had failed. That's a lot of steam traps. Again, it's a custom incentive. It's a prescriptive incentive. They received $53,600 for doing that, and estimated energy savings was about 230,000 therms. If you think that a therm is around 50 cents a therm, you can see that's about $115,000 in energy cost. So again, can't stress enough to go after your steam traps and get that survey done and get those steam traps fixed because the savings and the incentives are pretty nice.
Great. Thank you very much, Jerry. You've explained the process steam systems very well and to where even I can understand how they work and see how different ways that you can save energy in your process steam system. So thank you very much. At this time, I have another question for you all. I would like to hear from you. Do you see any opportunities at your facility for any of the opportunities that we have talked about today? Okay, like we have someone who interested in a steam trap survey. Great idea. Boiling up. It's a great time of year for that. Some others don't know. Well, very much. I'm going to go ahead and close the poll. Thank you so much for participating and letting us know. Wait for the results to come in so I can share the final results. You'll be able to already see those. Okay, it's tagged all the results for us there so you can see what everyone's responded. Thank you for your participation. Jerry is going to tell you a couple ways to get started on a project.
All right, thank you. You may be wondering how to get started on your process steam project. There are several options. First, to see if you can turn equipment you have. Take a piece of paper and just do block diagrams, big chunks. Put in their boiler and your distribution system and what are some of your major sources that use that steam. And when I say return, again, just do a simple walkthrough. Get you started. Just conduct a survey of your steam traps, and I mentioned that. It's a great way to understand how big your system really is. There's send it there for both the survey and fix the trap. So that's a great way to get started. This way to get started, if you need help, is a good energy advisor. Energy advisors are valuable tools to you. Again, at no cost. You got experts in the field that come out and help you get your program started. And the energy advisors are split up by quadrants. So depending on what quadrant you're in, if you're in quadrant 3, you'd be getting hold of Rhodes, and he can help you out as well. So please take advantage of these opportunities for you to help get your program moving in the right direction. Another way of doing it is going to the website. The program website and finding a program ally. Find a contractor who is a Act on Energy program ally. Again, some of these contractors, you get a hold of them, come in, and they help you get started. So please take advantage of this as well. You can move around the website. You come on the website, just find the contractor, click on it, and you can do a search on stuff you're looking for, the areas you served, and what kind of a customer you are. Hit this button, and you'll get a list of allies that you can contact and have come in and get your program going as well. So, and please use these resources. Last one here is a website. This is www.actonenergy.com. And again, you get that website. There's a lot of information on that website. If you have a question or you want to get more information, don't hesitate to call 866-800-0747, or you can also email the program at actonenergybusiness@amarin.com. And if you need something on the natural gas or technical reviewer, I gave Dave's number here, email as well. A few resource. Steam source book. There's a website, energy.gov, best practices, and then you can just click on the Steam source book. And it's a website. First, the Steam source book is excellent. It's free. It's full of a lot of good information. I actually use the Steam source book when I developed curriculum for the University of Wisconsin, Madison. There's also a lot of other source books there as well. There's a fan. There's compressed air. If you wanted some information on your compressed air system up to snuff. So a lot of source books, and again, free. Download them, print them out, or whatever. I highly recommend that you take a look at those source books. Sheets. There's all kinds of tip sheets, best practices, if you will, on different ideas. Again, go to the EERE website. Practices, and then there's a whole slew of tip sheets, and you can click on a tip sheet that meets your particular question. And again, these tip sheets are extremely good. It's not just steam; it's again all the different areas, like I mentioned before: lighting, steam, compressed air, fans, pumps, etc. Then your technical fact sheets. It's the same site. You can bring those up as well. If you haven't been to this website, www.1.eereenergy.gov, I recommend. I visit that. I don't know, but maybe every other week. I'm usually on those websites trying to find something. And again, it just gives me some information that I might need real quick, and that's the place I go. So take that website. It's a great website. Sources is Smart Energy Design Assistance Center. the energy assessments, and depending on how big you are, will determine the cost and the ability to get those done for your facility. Department of Commerce and Economic Opportunity program and the different bureaus, recycling and energy. Take a look at those if you need some additional information. And I think that's it.
Well, thank you very much, Jerry, going over the ways that we can get started, and we really appreciate you joining us today. Now it is time for the final quiz that I promised you, so I'm going to go ahead and open the quiz, and if you could please submit your responses, and you'll have about a minute. Looks like most of you have submitted your responses, so I'm going to go ahead and close the poll. 3, 2, 1. And I will go ahead and share the results, and we'll go over the correct answers. Looks like most of you got these correct. For number 1, in steam systems that have not been maintained in 3 to 5 years, the answer is D. Between 15 and 30% of the steam traps that are installed may have failed. A lot. And 2, true, many low-cost steam system improvements have payback of less than 2 years. That is true. Absolutely. And number 3, how much of the heat generated by a steam boiler is carried away by the exhaust flue? That is 20%. So great job, and thank you very much for participating in the quiz. Once again, these are the Act on Energy resources. In order to contact the program, you can email or call if you have any questions. And it looks like we do have a couple of questions that people have submitted. If you have any additional questions, please type them into the chat feature now. And we have those answered for you, so I'll give you a minute to do that, and I'll go over a couple of upcoming events to let you know about while you are typing those questions into chat. What I wanted to let you know is that you are going to be receiving that email with a request to complete a survey about your experience during the learning event today. So please complete that survey and let us know what you liked about the event and how it can be improved. I'd also like to let you know about a couple of upcoming Act on Energy webinars in October. October 10th, we have Mark Bayer and John Bentema who will be talking about energy efficiency measures for industrial facilities. And on October 24th, I'm going to be talking about budgeting considerations for energy efficiency projects and how to get buy-in from the upper management to be able to get these projects done. Also, we are offering Certified Energy Auditor. It's a professional designation through the Association of Energy Engineers, and we're offering that in Springfield in March next year.